All right, double a number is equal to the number decreased by 5. Find the number. Double a number is 2 times the number. Is equal to the number decreased by 5. But they don't care about the equation. They want you to actually find the number, which means solve for the x. This is like a 1x, so you subtract 1x on this side, it cancels. You subtract it on this side, and you get 1x. And you don't have to write the 1. And then all that's left on the other side is the answer. -5. Yes? We are working on page, I believe we didn't finish 15. Okay, turn to page 15. What do we have to do? Just the 2 bottom problems? All right, number 19. The volume of a box V is given by the formula V equals LWH, where L is the length, W is the width, and H is the height. Part A wants you to solve the formula for H. So V equals LWH, and they want you to solve that for H. How do we do that? You just get all of the all the variables away from it. How are the other variables attached to the H? They're being multiplied, and since both of them are being multiplied, then you can divide both of them at the same time. So we're going to divide by LW, and those both cancel out, leaving H by itself like we wanted. And then over here, we're going to divide by LW. And so H equals V over L times W. Or you could go ahead and rearrange it. I prefer to write H first, since that's the variable I was solving for. And the property that says that I can do that I can just reverse the sides, is called the symmetric property. Okay, we're going to start learning properties next week, but I'm going to go ahead and start talking about them now. Like, we know what distributive property is. We've been talking about commutative property, and now we're talking about symmetric property, because next week you're going to have to learn them all. Okay, so the property that says I can flip-flop it like that at the end is called the symmetric property. Now, the reason that we solved for H is because in part B, they want us to figure out the height of a box with a volume of 50 cubic meters, a length of 10 meters, and a width of 2 meters. So we're trying to figure out the height, so H is unknown. But in the V place, which is volume, we can put 50, because it says volume of 50 cubic meters. In the L place, we can put 10, because it says length of 10 meters. And then in the W place, we can put a 2. What do we do with the 10 and 2? We multiply them, and the bottom becomes 20. Now we're going to simplify 50 over 20. What's 50 divided by 20? 2.5. So that means the height of this box is 2.5 meters. All right, number 20. Everybody got it copied? Okay, number 20. Trent purchases 44 euros worth of souvenirs while on vacation in France. If 1 US dollar equals 0.678 euros, find the cost of the souvenirs in United States dollars and round it to the nearest cent. Okay, the given information is 44 euros. That's what he's purchasing when he gets to France. We want to convert this to dollars to see how much money he's really spending, because, yeah, I mean, we all hear 44 euros, but for us, we don't really understand what that means because we're not familiar with the value of a euro, right? So we're going to convert it to dollars using a conversion chain. What units has to be down here? Euros. Because remember, whatever was in the top goes in the bottom of the next fraction so that they'll cancel out at the end. And what do we know about euros? Right, 1 US dollar is 0.678 euros. Now I'm finished with my conversion chain because I've made it to the desired units of dollars. So I cancel out euros with euros. In the numerators, I have a 44 and a 1, so that makes 44 when I multiply them. And then there's only one denominator, so just bring it over. Now when you divide that, keep in mind that our answer is in dollars. And how many dollars is that? And right. Why did it round to 90 cents? Well, it was 8, 9, 6. And since that third number was 5 or greater, it's going to make it jump up to 90 cents. Okay, now turn to page 16. Okay, today we're going to continue practicing solving literal equations for the first half, and then the second half we're going to move on to the new lesson. So number 1, D equals RT, and they want you to solve this for R. How do you get this R by itself? Correct. It's being multiplied by T, so the inverse of multiplication is division. So divide by T on both sides. D over T now equals R, because the T's cancel out. Or if you wanted to, you can rewrite it as R equals D over T. And what property says I can do that? Symmetric property. This is what the property actually states, and we'll talk about this more next week. It says if A equals B, then B equals A. That's what the symmetric property says. They're the same thing even if you reverse the order, or reverse the sides. Okay, number 3. You can just lay them right there. Mx plus 4y equals 3t, and they want you to solve this for x. So to get x by itself, we need to get the m to the other side and all of the 4y to the other side. What do we move first? Right, and since it's plus 4y, u minus 4y. Those cancel, leaving mx on the left side of the equal sign and 3t minus 4y on the right. Now to solve for x, what do we do? Divide by m and divide this whole side by m. The m's cancel out, leaving x by itself. And if this were free response and you wrote it like that, I would accept that as a correct answer. But on the test, more than likely, they're going to split it into two fractions, 3t over m minus 4y over m. All right, number 5. AB plus 3C equals 2x, and they want us to solve it for B. So what do we do first? Right, subtract the 3C on both sides. That becomes AB on the left, and on the right you can't actually subtract it, so you just write it off. Now to solve for B, what do we do? Correct, because we want to cancel out the A. And then we divide this whole side by A, and now we technically have the right answer because B's by itself, and that's what it equals. But remember, you may see them write it like this. B equals 2x over A minus 3C over A. And we'll get to one later where you're going to see why they split it up. Okay, number 7. 2/3 m plus a equals a plus r. Solve it for m. First, let's subtract this a to get it away from the m, and it cancels, leaving just the 2/3 m on the left side of the equation. Then when we go over here and subtract it, there's something to subtract it from, another a, and what happens? Those cancel as well, leaving just the r. Now to get m by itself, what do we do? Right. It is multiplication right now, and so normally we would divide. But instead of dividing a fraction by another fraction, I taught you to keep it, change it, flip it, which you actually learned in middle school. You multiply by the reciprocal on both sides. Now the reason that cancels out is because look, 3 over 3 is 1, 2 over 2 is 1, and there's no need to write the 1 beside the m. On the right side, we're going to write this how? Don't we always write that coefficient first and then the variable second with no sign in between? All right, number 9. 2/3 y plus v, I think it's a fancy v, equals x, and they want us to solve it for y. Okay, what do I do first? Right? Those cancel, leaving 2/3 y equal to x minus v. Now what do we do to get y by itself? Correct, but watch so that you don't miss this. On this side, when you multiply by the reciprocal, everything cancels out, leaving y by itself. But then when you go to this side and multiply by the reciprocal, you're multiplying the entire thing by 3/2. And so you put parentheses, showing that all of it's being multiplied by 3/2. Okay, not just the x, not just the v, but everything on that side gets multiplied by 3/2. Now, you may see them normally when you have something like this, they end up writing the number in the front. Or you may even see this. They may go ahead and distribute that 3/2 and get 3/2x minus 3/2v. They may go and distribute it through the parentheses. Any questions about that one? Okay, number 11. Rx plus 9/5 equals h. Solve for x. So what do? Multiply by 5 on both sides. Those cancel, leaving Rx plus 9 equal to 5h. Now to solve for x, what do? Right? And so those cancel, leaving Rx. And then on the right, you can't actually subtract those, so you just rewrite it. And now to solve for x, we divide by r, so x equals All right, number 13. 2w minus y equals 7w minus 2, and they want it to solve for w. But anytime they're asking you to solve for the variable and there's more than one of that variable, what do you have to do first? Combine like terms. So do you want to move the 2w over to the 7w or the 7w over to the 2w? It doesn't really matter. It's just preference. A lot of people like for the variable they're solving for to end up on the left. So we'll subtract the 7w, cancel it on that side, and move it to the left side, making that how many w's? -5. Then we'll bring down this minus y and the equal sign and the -2. Now to solve for w, what do we have to do next? Correct. Add the y. Those cancel, leaving -5w equal to -2 plus y. And now to solve for w, what do? Divide by -5. Those cancel, leaving w by itself. Now watch. When we split it up, watch what happens. When you put the 2 over the 5, both of them are negative. And a negative divided by negative is a positive. So that all becomes positive. When you put y over 5, though, this one's positive, this one's negative, and a positive divided by negative is negative. So -y over 5. If you wrote a plus sign and then wrote a negative after that, yeah, it is, but on the test, you're going to see them simplify it down to one sign, and anytime they're opposites, you put a minus. Okay, now we're going to move on for right now to something completely different. So turn to page 20. Today we're going to be reviewing something you learned in middle school. It's called graphing linear equations. Now, we're going to sketch the graph of each line. How do I know that that's the equation of a line? Right. Courtney got it. It's in y equals mx plus b form. Okay, the equation of a line is always in y equals mx plus b form. This is also called slope-intercept form. Because this is the slope, this is the y-intercept. That's why it's called slope-intercept form. Now, the m is your slope, and what is the m in this equation? -2. Okay, slope is also sometimes referred to as rise over run. So a fraction. Well, we have a whole number. How can we make that whole number a fraction? Correct. And then we know that our -2 is our rise and our +1 is our run. You rise up or down. Up or down is your rise. So -2 would be up 2 or down 2? Down 2. And then a +1, you run left and right. So +1 would be left or right? Right. Okay, now you can't actually do those directions though until you have a starting point. And the starting point is your y-intercept, which is your b value, -3. So this is called your y-intercept. And so of course you would plot that on the y-axis, the vertical axis. So we go to -3 and plot our y-intercept, which is also our starting point. We always do that first. And then from there, we follow the directions. The directions say down 2, right 1. So down 2, right 1. Now, could I go down 2, right 1 again? No, because I've run out of graph. So how can I get a third point on there? The exact opposite. Up 2, left 1. And see how that point still stays in line with the other two? And you can do that as long as you have graph available. Up 2, left 1, up 2, left 1, up 2, left 1. Now, you don't really have to have more than 2 points to graph a line. However, we're going to be moving into graphing linear inequalities, and it's best when you're doing those to have a lot of points. So I would just stay in the habit of plotting as many points as you can. Okay, once you've plotted your points, you need to connect them with a line. If you want a ruler, there's some up here in the blue drawer, the second blue drawer. Look at number 2. This is in the form y = mx plus b, which is called slope-intercept form. It's called that because it has a slope in it and a y-intercept, slope-intercept form. When you graph something in slope-intercept form, it will form a line on the graph. To form that line, you have to know 2 important things. The slope, which is m, and the b, which is y-intercept. What is the slope? 1/5. Now, another thing that we call slope is rise over run. Okay, so you always want your slope to be in fraction form for that reason. Rise is up and down, run is left and right. So would a +1 be up 1 or down 1? Up 1. Would a +5 be left 5 or right 5? Right 5. Okay, now our starting point is our y-intercept, our b value, which in this case is 2. We always plot the b value on the y-axis because it's the y-intercept, and then from there we follow the directions. Up 1, right 5, or the exact opposite, down 1, left 5. Once you have as many points as you can get, you connect the points with a straight line, and you are done. Correct. I was about to talk about that. Okay, everybody look up at the 2 we've graphed so far. Why is number 1 going down and number 2 is going up? No, it's the slope. Your b, your y-intercept just tells you where you're going to cross the y-axis. It does not determine whether you go up or down. The m, being a -2, made this line go down. This m, being a +1/5, made it go up. Okay, now even more important, well, not necessarily more important, just something that y'all don't know as well. Why is number 1's line so much steeper? Steeper. Well, yes and no. It's a whole number 2. The negative is just making it go down. The steepness is caused by it being a 2. Isn't 1/5 0.2? And see, the bigger the number, the steeper the line. The smaller the number, the less steep. all the way down to, like, if you get to 0 slope, no steepness at all, a horizontal line. Okay, so like right now that would be considered 0 slope because there's no steepness. If you go up a little, that might be like a slope of 1, slope of 2, slope of 3, 4, 5. The bigger your slope value gets, the steeper it gets. And then undefined is completely vertical. Same thing for negative. Like this might be a slope of -1, -2, -3, -4, -5. Completely vertical is slope of undefined. Completely horizontal with no steepness at all is slope of 0. So the smaller your number, the closer it is to 0, the less steep. The larger your number gets, the more steep. And then, of course, the negative made it go down. The positive makes it go up. Okay, now let's look at number 3 and 4. This is an equation in slope-intercept form. What is the slope? The m. Right? Right, we want to go ahead and throw it over 1 because slope is also known as rise over run. Rise will take you up or down. In this case, it's going to take us down because it's -5. Run will move you left and right. In this case, it's going to move you right because positive is right. But before we even do anything with that, we have to have our starting point, which is called the y-intercept, and it is at 5. So you go up to +5, plot your y-intercept, and then from there to get to your next point, down 5, right 1. And then you have room to do it again. Down 5, right 1. No, this one's really steep. It's just really steep because its slope was a large number, 5. It's going down because it was a negative number. Yes, Naya? You just don't. You just, like, you count like the box. 1, 2, 3, 4, 5, and then over 1. Yeah, you don't count the actual dot of the point. Okay, number 4. Y equals mx plus b. What is the m? Correct. What is, so that means we're going to go what 5? Up 5 and right 1. But before we can do that, we have to plot our starting point at 2. That's our y-intercept. And then from there we go up 1, 2, 3, 4, 5 over 1, which really runs off the graph. So instead we should have gone correct. Okay, then you connect those lines, or connect those points with a line. And it's okay to plot a point off the graph. If it barely goes off and you know exactly where the point should be, you can plot it. That's fine. Now, out of those two, which line is steeper? They're the same. Don't they both have a slope of 5? So the steepness is identical. They're the same steepness. It's just this one's going down because it's a -5. This one's going up because it's a +5. Okay, I want you to take a few minutes and try all problems on page 21 by yourself. That's 4 problems. And then after a few minutes, I'm going to reveal the answer so you can check your work. For page 21, so you can see if you did it right. That's what your line should look like on numbers 5 and 6. Okay, and then this is what your line should look like on 7 and 8. Out of those two, which line's steeper? Number 7 or number 8? Why? They're very close, but look, this is a slope of 2, right? Slope of 2. This is a slope of 2.5. 5 over 2 is 2.5. Isn't that a little bit bigger than that? So this is a little bit steeper, but it's hard to tell because those numbers are so close. Okay, so once you've checked your work, you can turn back and start working on the homework. It's page 16, the evens.